Hello and welcome to Tektronix. Today we're going to talk about advanced triggering, part 1 of a 5-video series. Part 1 covering edge, pulse width, and video triggering. So if we select our trigger menu followed by trigger type, we can use Multipurpose A to select our trigger type. Edge trigger is one of the most basic and commonly used trigger types. It triggers on a rising edge or falling edge as defined by the slope control. We can also choose our coupling. We can choose direct current, which allows both AC and DC signals through. Or we can choose alternating current, which accepts only AC signals so that we do not have any vertical offset in our waveform. The DC component and very low frequencies are blocked. This is most useful for triggering on an AC signal in the presence of large DC signals or slow varying AC signals. We could also select high frequency reject, which is similar to DC coupling, except the higher frequencies are rejected. This is especially useful for triggering on low frequency signals that have high frequency noise or other high frequency components riding on the main signal. Or we could also select low frequency reject, which is similar to AC coupling and is useful for rejecting signal interference. And lastly, we could select noise reject, which is similar to DC coupling, but the sensitivity is reduced to minimize false triggering on very noisy signals. We can select level and then use our Multipurpose A control to select our trigger level in volts. This is the same as using our trigger level control. We could choose a preset value for our trigger level, again using the Multipurpose A control. Or we could select set to 50%, just like we did earlier with our trigger level control. Lastly, we can select our trigger mode and hold off. The trigger mode determines how our scope behaves in the absence of trigger events. Normal trigger mode enables our scope to acquire a waveform only when it is triggered. If no trigger occurs, the last waveform record acquired remains on the display as you can see here. If no waveform exists, then no waveform is displayed. Auto trigger enables our scope to acquire a waveform even if a trigger does not occur. If a trigger event is not detected, the scope forces the trigger. When forcing a trigger in the absence of a valid trigger event, the waveform will appear to roll across the screen as seen here. Otherwise, a valid trigger yields a stable display as shown. We also have the option of changing our hold-off value using Multipurpose A. Hold-off is basically the amount of time that passes between each trigger acquisition while in run-stop mode. When dealing with a very simple and continuous waveform like we have here, we want to have a hold-off time as small as possible, which will allow us to have the most stable waveform possible. For example, if I change the hold-off to 1 second, you might see how the waveform appears to roll across the screen, but every second a trigger is acquired at the same location. We also have the option of setting our hold-off to the minimum value. Hold-off is also adjusted to obtain stable triggering when the scope is triggering on undesired triggering events. For example, here on a burst waveform, we don't want to trigger on every single rising edge. Doing so would result in the oscilloscope producing a very unstable waveform that would appear to roll across the screen like we saw earlier. We would rather trigger on the first edge of each burst, so we would adjust our hold-off as such. Now we can select pulse width as our trigger type. As before, we can choose our source and mode and hold-off. Our threshold is also identical to our trigger level control. We can trigger when our pulse width is less than, greater than, equal to, or not equal to a specified time value. We can select limit and use Multipurpose A to adjust our limit, and select single acquisition just to get a more clean and stable view of the waveform. We can also trigger when a pulse width is inside or outside a specified time range, using Multipurpose A to adjust our low limit, and Multipurpose B to adjust our high limit. Lastly, we can select our pulse width polarity, positive resulting in triggering on the falling edge, and negative, resulting in triggering on the rising edge, as seen by selecting single acquisition. Now I am using a multi-format test signal generator used for video equipment, which requires a 75 ohm resistor, and I am testing 75% color bars. And as you can see, I have selected video as our trigger type, NTSC video standard, and am currently triggering on all lines. We have the options of selecting our source, polarity, and mode and hold off as always. However, with video, we can change the hold off for both time and fields. Selecting video standard, we can see the many different video standards our products support. We can trigger on odd fields, even fields, all lines, or single lines. And we can use multipurpose A to select our line. By selecting line number, we can choose which field, odd or even, the line number comes from. We can even change our bilevel settings, which is standard definition, and our trilevel settings, which is high definition. I will select bilevel since we are using standard definition testing. Select settings, and we can choose progressive or interlaced. As well as change our line period using multipurpose A, and our sync interval using multipurpose B. Thank you for watching our video. If you'd like to learn more information about our products, please visit www.tektronix.com/support, or if you'd like to learn more about advanced triggering, please click on one of the links provided.